All right, now we're going to begin section 11.6, which is planes in space. All right, so first, let's talk about the equation of a plane. So given a point P naught with coordinates x naught, y naught, and z naught, on a plane, and what we'll call a normal vector, which we'll use a capital N to denote, with components A, B, and C. And normal vectors are what are called, so we're defining this at the same time as I'm introducing it. Normal vectors are what are called perpendicular to whatever plane it is that we're referencing. So a normal vector N perpendicular to the plane. So that's what it means to be a normal vector. It just means it's perpendicular to the plane. The equation of the plane is A times the quantity x minus x naught plus B times the quantity y minus y naught plus C times the quantity z minus z naught equals 0. Or you can also write it as ax plus by plus cz equals d, where d equals ax naught plus by naught plus cz naught. So in practice, when we are coming up with the equation of a plane, normally we stop and we leave it like that. But when you're given an equation of a plane, normally it's given this way. But notice some key elements here. First off, just like when we talked about the equation of a line, the key thing to know is what you need to find the equation of a line. You need a point on the line and a vector parallel to the line. To find the equation of a plane, key things to note are you need a point on the plane and a normal vector perpendicular to the plane. If you have those two things, then you can find the equation of a plane. Then another thing to be cognizant of is when you have the equation of a plane, normally it's going to be given this way. You'll rarely see it given to you that way. But what can you tell from this immediately? You can tell what your normal vector is. Your normal vector is A, B, C. So when you're given your equation of a plane that way, you can see your normal vector. Here, if you happen to be given the equation of a plane this way, you can see your normal vector A, B, C, and you can also see a point on the plane. So x naught, y naught, z naught. But we'll look at an example where you can easily find a point on the plane given the plane was given to you in this form as well. So it's not difficult to find a point on the plane in this scenario. All right, so a couple of things to keep in mind. So let me put boxes around these. A lot of times I avoid putting boxes around in the equation of a plane and lines because yes, this is important, but this is completely useless if you forget that you need a point on the plane and a normal vector to the plane. So you have to remember that along with this formula. All right, so a couple of things to keep in mind. keep in mind that 3 points determine a plane. All 3 points are on the plane. So if you're given 3 points, you automatically have a plane that corresponds to those 3 points. Just like in the past, if you were given 2 points, those 2 points determine a line. Any 3 points determine a plane. Now, this equation that we have, or that we have up here, also tells us, or this definition we have up here, also tells us that yes, if we have 3 points, we have a plane. And we can also find the equation of a plane if we have 1 point on a plane and a vector perpendicular to the plane. So 1 point on a plane and a vector perpendicular to the plane also determine a plane. So this second asterisk here, if they point on a plane, a vector perpendicular determine a plane, but that's the technique that we'll also use to find the equation of a plane as well. All right, so let's look at an example. So we will, on page 747 in your textbook, and we will start with number 7, which says find the equation of the plane that contains the point 1, negative 1, 2, and the line with symmetric equations x plus 2 equals y plus 1 equals z plus 5 over 2. So we want an equation of a plane. Find the equation of the plane. So when you see that, your immediate thought should be, okay, I need a point on the plane and I need a vector perpendicular to the plane. Those are the key things I'm looking for so I can find the equation. It tells us find the equation of the plane that contains, so they give us a point P naught, 1, negative 1, 2. So we are halfway there. We already have a point on the plane. We just need a vector that's perpendicular to the plane, or a normal vector. And the line with symmetric equation. So it contains this and it contains this line. X plus 2 equals y plus 1 equals z plus 5 over 2. So, all right, so now we have a point on the plane and we have a line that's in the plane. So to make our lives easy, we're going to make this paper, which be our plane. So we'll say this is a point. And I'm still working in 3 dimensions. This paper, if we're in real life, we're always in 3 dimensions. So it could be that this plane, for instance, is this slanted, the actual plane that we're considering is this particular plane, just to make our lives easy so you can see, instead of me trying to write on this plane that's slanted, I'm taking this plane and I'm putting it down on my paper to make our lives a little bit easier. So we're still working in 3 dimensions, although I'm just taking the plane and I'm putting it down on my page so I can write a little bit easier. So we'll make this our point. So this is P naught, which is 1, negative 1, 2. We know that's in the plane. And we also know this line is in the plane. So let's just draw this line wherever we want to. This line actually, there probably is the relationship between this point and the line I probably could figure out a little bit better, but that's not necessary. I'm just trying to make a point here. So we'll call this line script L. So the piece of paper is our plane. So we have a point in the plane and we have a line in the plane. What do we need though? We need a point in the plane, which we have that one. And we also have infinitely many other ones, but it's easy to use that one. And then we need a normal vector. So I need a vector that is perpendicular to the plane. But I have to find that vector. All right, so how do we go about finding that vector given the information that we have? Put the vector over here so it's kind of out of the way. Given the information that we have. So we can use one of these key tidbits of information. So 3 points determine a plane, so that could help us. Now we want, the only way that we know to come up with a new vector so far from our skill set that we have is working with the cross product. So cross product requires that we have two vectors. Right now we don't have any vectors. We have a point and a line. But inherent in this line is its vector capital L that's parallel to it. So if we look at these symmetric equations, we can find what capital L is parallel to this. So this is the same as x plus 2 over 1. That's the same as y plus 1 over 1. Now be careful with just automatically putting stuff over 1. The reason I was able to do that is because these coefficients, that was positive. This has a positive 1 there, a positive 1 there, and a positive 1 there. So I can do that. Otherwise, I might have to manipulate a little bit more. So that tells me that the vector capital L that's parallel to this line right here is 1, 1, 2. So let's just go ahead and say capital L is 1, 1, 2. And remember, when we use the capital L, we're talking about a vector parallel to the line that we're considering. So now what we have is, let's just go ahead and say capital L is right there. So now we have this capital L that's parallel to that. So we still don't have two vectors to take a cross product with, but what we can do is we can make a vector using this point and any other point that we want to in this plane. So an easy point that we know is in the plane is we could pull one from here. So we know that with these symmetric equations, that's the same as x minus negative 2 over 1 equals y minus negative 1 over 1 equals z minus negative 5 over 2. So we have a point as well. And again, I'm not being true to where these things are. I'm just putting this together for visual purposes. Negative 2, negative 1, negative 5. To make my life easy, I'm going to put that right here. So let's call it Q. And it was negative 2, negative 1, negative 5. Oops, that should have been on the line. Sorry. Remember, that point that I pulled was a point that was on our line because I pulled it from this equation right here. So here's Q. So now what we can do is we can find another vector, PQ naught or P naught Q, doesn't matter which one you find. And then we can take that vector. So now we have this new vector right here. And we can do the cross product of this vector with that vector to get a vector that's perpendicular to our page. So we can get that vector that we need. Then we'll have a normal vector for the plane, and we'll have a point, this point or that point, doesn't matter which point you use, or any other point that's on this plane. So let's go ahead and find this cross product and then find our normal vector, and then we can find the equation of our plane. So our normal vector n is going to be equal to L cross with, let's say, P naught Q. So let's find what P naught Q is. All right, so remember, if we're doing P naught Q, we're going to do -2 minus 1. And then we're going to do -1 minus -1. And then -5 minus 2. All right, now we can do this vector L, 1, 1, 2, cross with this vector -3, 0, -7. So we were doing L cross P naught Q. So I, J, K. And 1, 1, 2. And -3, 0, -7. So this is equal to 1 times -7, so -7, and then -0 times I, and then a minus sign, and then 1 times -7, which gives a -7, and then minus the -6, so -7 plus 6, which gives us -1. And that's in the J direction. And then plus 1 times 0 gives us 0, and then minus the -3, which gives us a +3. So that's our normal vector. So our normal vector N is -7, 1, 3. So now with that, what we're going to do is we need our equation, which let me have a little refresher. So A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals 0. So this is our A, B, and C. So just as a reminder, that's A, B, C. Then our X naught, our Y naught, and our Z naught is any point you want to use this on the plane. So we had our P naught that they gave us, so we'll use that point. We also had the other point that we pulled from our line, but we'll use P naught. So our A is -7 times X minus our X naught was 1, plus our B was 1, and then Y minus our Y naught was -1. And then our C is 3 times Z minus our Z naught is 2 equals 0. And remember, this X naught, Y naught, Z naught came from our point P naught, but it's any point that you want to use on your plane. So this right here would be the equation to that plane that we're asking about. All right, so I'll stop this video here, and then I'll do a couple more examples from 11.6 in the next video.